The objectives for this video are to learn how to compute the test value for a hypothesis test about the difference between population variances, and to learn how to draw a conclusion for a hypothesis test about the difference between population variances. In part 1 of this series of videos on hypothesis testing about the difference between two variances, we learned about the characteristics of the F distribution and how to find a critical value. Step 3 is to compute the test value. Recall that the formula for the F test value is to divide the larger variance by the smaller. Carrying out this calculation, we will find an F test value of 1.575. Step 4 is to make the decision. Recall that it was stated that the F distribution consists of a family of curves. This particular curve represents the F distribution for 21 numerator degrees of freedom and 19 denominator degrees of freedom. Recall also that the F test value will always be positive. So if there is enough difference between the variances for the two groups, the ratio will become large. Our critical value this time is 2.51. Our F test value is 1.575. This value clearly lands in the region where we would not reject the null hypothesis. So in other words, there was not enough difference between the variances so that the ratio would be greater than 2.51. So our decision should then be, do not reject the null hypothesis. Step 5 is to summarize the results. Since we will not reject the null hypothesis, we should state that there is not enough evidence to support the claim that a difference exists in the variances of the average household income per county between the two states. In this video, we learned how to compute the test value for a hypothesis test about the difference between population variances, and we learned how to draw a conclusion for a hypothesis test about the difference between population variances.